Hello mga ka-tribes! Welcome to Daddy Brew TV. For today's video, let's talk about part 3 of lesson 1, quarter 4, which is sampling distribution without replacement. Okay, example. A population consists of three numbers, 2, 4, and 6. Consider all possible samples of size 2 which can be drawn without replacement from the population. Find the following. A. Population mean. B. Population variance. C. Population standard deviation. D. Mean of each sample of the mean of the sampling distribution of means. E. Variance of sampling distribution of means. And F. Standard deviation of the sampling distribution of the means. To find the population mean, let's construct the table of the experiment. Now, a population consists of three numbers, right? So therefore, there are three observations. 1, 2, 3. Now, the first observation consists of the number 2. Second observation, 4. And the third observation consists of the number or population number 6. Okay? So, let's get the summation now of these population numbers. 2 plus 4 is 6 plus 6 is 12. Okay? So, that is the summation now of the population number. Now, we are now ready to define the population mean. For A, we will use the formula population mean or mu equal now to the summation of x divided by capital N. Okay? So what is our summation of x? That is equal to 12 divided by n, which is equal to 3, meaning 3 observations only. So 12 divided by 3 is equal to 4. Therefore, 4 is the population mean. Now, to get the population variance, let's continue working with our table. We will subtract the population number to our population mean 4. So that is 2 minus 4 equal to negative 2. 4 minus 4 equal to 0. 6 minus 4 is equal to 2. Then let's square the difference. So the square of negative 2 is positive 4. Square of 0 is 0. The square of 2 is positive 4. So getting the sum, that is 4 plus 0 plus 4 is equal to 8. Okay, using now this data, we are now ready to define the population variance. Okay, so for our population variance, we will use the formula sigma squared is equal now to the summation of the quantity x minus mu quantity squared over capital N. So what is our summation of x minus mu squared? That is equal to 8. Divide by our n, 3 observations. So the quotient is 2.67. And 2.67 is our sigma squared or known as the population variance. Of course, to determine the population standard deviation, just simply extract the square root of the variance. That is the square root now of 8 over 3 or the square root of 2.67. And that is 1.63. For question D, to find the mean of each sample and the mean of the sampling distribution of means, let's construct a table of values. Now, on our first column, there are 6 observations. Why? Because for a population number with 3 and a sample size of 2, we obtain the sample 2 and 4, 2, 6, 4, 2, 4, 6, 6, 2, and 6, 4. So take note, without replacement, so therefore there are only 6 sample. Now, let's determine now the mean. How? Just simply add 2 and 4, divide by 2, that is equal to 3. 2 plus 6, divide by 2, equal to 4. 4 plus 2 divided by 2 is equal to 3. 4 plus 6 divided by 2 equal to 5. 6 plus 2 divided by 2 is equal to 4. 6 plus 4 divided by 2 is equal to 5. So getting now the summation of the mean, that is now equal to 24. So since we have already the summation of the mean, let's now ready to define the mean of the sampling distribution of mean, denoted by the formula mu sub x bar is equal to the summation of the means divided by n, or small n. So what is our summation of the means? 24 divided by 6 observations, and that is 4. And 4 is the mean of the sampling distribution of means. Now, to find the variance of the sampling distribution of means, let's continue our table. On our fourth column, you can see the difference of the mean and the sample mean. Okay, and that is 3 minus 4 equal to negative 1. 4 minus 4 is equal to 0. 3 minus 4 is equal to negative 1. 5 minus 4 is equal to 1. 4 minus 4 is equal to 0. 5 minus 4 is equal to 1. Squaring the difference, that is now 1 if it is negative 1. Square of 0, 0 also. Square of negative 1 is positive 1. Square of 1 is also positive 1. Square of 0 is 0. Square of 1 is 1. Take note, the squares are all positive. Now, let's get the sum, or the summation. That is 1 plus 1 plus 1 plus 1 is equal to 4. Okay, we have now a data for the summation of the mean minus the sample mean squared. We are now ready to find the variance of the sampling distribution of the means. That is denoted by this formula. So what is our summation of the mean minus the mean squared? That is 4 over 6 observations. That is 2/3. And 2/3 is equivalent to 0.67 or 67 hundredths. Of course, to determine the standard deviation of the sampling distribution of means, just simply extract the variance. That is square root now of 4 over 6, which is now equal to 0.816 or 0.82 or 82 hundredths. And that is the standard deviation of the sampling distribution of means. Now, let me show to you guys an alternative method to find the variance of the sampling distribution of mean if all possible random samples of size n are chosen from a finite population without replacement. Use this formula, okay, where sigma squared is equal to the population variance, capital N is the population size, small n is the sample size, and of course sigma squared sub x bar is the variance of the sampling distribution of mean. Okay, of course, to find the standard deviation, just extract the square root. Now, let's do it. Okay, look at this solution. Our population variance is 2.67 divided by n, meaning the sample size 2, times the population size is 3 minus the sample size 2 divided by population size 3 minus 1. And that is now equal to 0.67. That is the variance of the sampling distribution of mean, which is equal to our conventional solution, 0.67. Now, for the square root or standard deviation, we obtain 0.82 if we simply extract the square root, which is also equal to the conventional solution. Okay, 0.82. Okay, so it's up to you guys to use this alternative if you want easy or short way to find the variance of the sampling distribution of means and the standard deviations. So that's all for now. Thank you for watching. See you on my next video. Bye.